Today I'm going to go over a new kind of Sorites problem. So we have the Sorites set up here, but you'll notice that we've got some complements. So we don't have, we need to reduce the terms. So we've got an extra step here where we're going to have to use the immediate inferences, conversion, contraposition, obversion in order to reduce these terms. I'm going to carry those over here, and then once we have all the terms reduced, then we're going to put it into standard form, and then we can go through the process of the Sorites just like I did in the last few videos. So let's get started. I like to make myself little notes just to kind of declutter my mind, give myself all the options that I can use. So first up, let's identify which terms we need to reduce. So D, we've got D. So those two are the same, so we're going to try to keep them the same if we can. So we've got non-C and we've got C. So I'm just going to underline that for now so that highlights. And then non-B, we've got B. So those ones we're going to have to reduce. Non-A, those are good. We're going to keep them the same if we can. Sometimes you have to change them up. And then E, and we've got non-E. So we're going to have to change it to either E or non-E. Change them both. And then D and D, we've already looked at that. B, B, C, I think we got all of them. Okay, so, and this is one, I'm sure there's other ways to reduce terms, and your argument will look a little different, but the statements will actually be logically equivalent if you've done your immediate inferences correctly. So after watching this video, if you end up with the same conclusion, but your argument, your terms that you've used look a little bit different, and you're not sure if you've used the immediate inferences correctly, just shoot me an email or ask me in class, and I'll check through your immediate inferences. So there may be several different ways to do this, but this is the one I've got. So all D or non-C, we can just kind of look top to bottom at things that we want to change. Actually, let's do this first. I like to identify the statements that we have. So A statement, I have an I statement, A statement, and then some are not. That's an O statement. And then just kind of go through the graph that we have of which ones we can use. You can always, you can always use obversion for anything, because that goes for A, E, I, and O statements. And then contraposition or conversion. Contraposition you can use for validly use for A and O statements. So I'm going to abbreviate that with T. So I can use, this is just kind of a reminder. Again, you don't have to do this, but I like to do it to remind myself what immediate inferences I have at my disposal for each statement. So I'll use T to represent contraposition, and then actually the O statement I can use contraposition. So we have one I statement, we can't do contraposition, but we can do conversion. I'll use a V for that. So that just tells me what my options are. Put a line here so it doesn't get confusing. Actually, I'm going to switch to red here so that we can see the difference. So the first one, we're going to have to reduce non-C to C or vice versa. But I noticed that I can do contraposition because it's an A statement. Oh, actually, the first one I'll use obversion, because that one won't change the D that I want to keep the same, but it will change the non-C to C, and then we can reduce those terms. So let's just carry that over here. Sorry. Op version, we're going to be changing the quality and complementing the predicate. So change the quality to no. D stays the same. No D, R, and then complement the non-C. So we're gonna have no D or C. And then, since I'm doing the underline, let's just get rid of those lines so that we know that that one's already reduced. All non-B or non-A, we have to reduce the terms between non-B and B. So looking at that, I can do, version's not going to do anything because it's going to change the non-A, but I can do contraposition. Let's go ahead and try that. So we're flipping the terms. We're switching non-A and non-B and then complementing each of them. So the quality stays the same. So that'll be all A, R, B. So we can erase this for now because those are reduced. But there's a new problem that we switched A. So we're going to have to underline the A's we're going to have to reduce. Some E or D. D is the same. E, we can change there. But you'll notice that if we can keep these two premises the same, if we can do contraposition on this, which is going to change both of these. So non-A will become A, non-E will become E, and then we'll be matched up here, and then we'll also be matched up with the new A. So let's go ahead. I'm pretty sure that'll work. So let's go ahead and fill these in. Some E, R, D. All B or C. And then carry over our conclusion. And again, we're going to do, this is no statement, so we can do contraposition to reduce both of those terms. So the quality is going to stay the same. Some are not. And then we're going to flip these two terms and complement each of them. We're going to have some E are not A. And let's just double check and make sure that we have everything reduced. D, D, we're good there. C, C, we're good there. A, B, B, E, E. Looks like we're all good. Everything's reduced. I'm going to switch back to the green marker. So we can kind of cross that out of our mind because we have everything reduced. So now we're back to step one of what we were doing before, of just carrying out the Sorites. So we're going to, before we get to the Venn diagrams, we need the correct order. So we need to put this into standard form now. And the way that you do that is identify the major term. So the conclusion is going to stay the same. This is the major term, the predicate of the conclusion. So we're looking for the premise with A in it. So our first premise is going to be all A are B. Second term that's used is B. There should be one other premise that has B in it. All B are C. Carry that over. C. Used up the B's. Next term is C. Next premise with C in it is no D or C. I'm going to leave a little gap for the subconclusion. No D or C. And then we've used up the C's. Next term is D. And our last premise has D in it. Some E are D. Leave a little space for the subconclusion. No, some E are D. All right. Yeah. R, B. And then we carry over our conclusion, which middle term we've used up to D. Our conclusion should have E in it. Some E are not A. And just to double check, we've used up the middle term, or the middle term of these two is E. So we've used up the E. Make sure that the other term should be back used in your first premise, and it is A. All right, we can go through the steps and test for validity. So same process as before. We'll look at the first two premises and make a Venn diagram with those. Term that's used twice is the middle term B. Then we have A and C. All A or B. I'm going to shade out that crescent on the top left. All B or C. Shade out the crescent on the bottom left. Look at those top two circles. See if one of those three shapes, remember the crescent on the left, football in the middle, crescent on the right, one of those is shaded out, and indeed we have the entire crescent on the left completely shaded out. So that tells me that all A are C. All A, since we've eliminated this part, are going to be part of the C circle. So carry over the subconclusion, all A are C. Then we're gonna do a second Venn diagram with those two. C is used twice, that goes at the bottom. A and D, the two on top. All A or C. I'm going to shade out this crescent at the top left. And then no D or C. Shade out that football between D and C. And we'll notice that we've shaded out that football between A and D. So that is telling us that no A are D. We're going to do one last Venn diagram with those two premises, no ARD and some ERD. So the subconclusion from the last one, no ARD, becomes our first premise. And some ERD. D is used twice, so that goes down at the bottom. A and E. We have no ARD. We're going to shade out the football between A and D. Some ERD. So that X is going to go down in that space right there. We've already shaded out the other half right there. And then we're going to look at the conclusion. So what the conclusion is asking us, some E are not A. So we're focusing in on the top two circles here, because we're only concerned with E and A. Some E are not A. It's asking us if there's an X somewhere in that crescent shape on the right. And we do have one right here. Again, doesn't matter if it's on top or the bottom, as long as there is an X, an unambiguous X, a non-fence straddling X, somewhere in that crescent shape. So this Sorites is valid.